we did an activity yesterday that went through this triangle inequality theorem. I posted it as an announcement on Canvas this morning, a link to it, so that you could see it and try it out yourself if you would like. So that you could see how and why this works, and why we need this, this idea. Triangle inequality theorem says that the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. And the way that we're going to use this more often is to say that if I add up the two shorter sides in the triangle, it has to be bigger than the longest side. In other words, if that doesn't happen, then it is impossible to make the triangle. The triangle can't happen. And again, the activity will go through that, but let me give you an example here. Let's say that I have a triangle, and I tell you to make a triangle, and the first side that I ask you to use is 2 inches long. And the second side that I ask you to use is 3 inches long. And then if I say, okay, I want the third side, not the fourth side, there are only 3 sides in a triangle. If I want the third side to be 4 inches, there's the 4. If I want that side to be 4 inches, well then, that's great. I may need to tweak where these sides are a little bit to make the 4 fit properly and to close and create a triangle, but I could do it. And triangle inequality theorem says I can, because 2 plus 3, the shorter sides, are bigger than 4, the longest side. The problem comes in when I say, okay, I want the first side to be 2, the second side to be 3 inches, and then the third side to be 8 million inches. No way that's going to fit. And mathematically, 2 plus 3, it's smaller than 8 million. And so we can't make a triangle. So that is the idea that we're looking at. So here's a pretty basic example of that. We say the lengths of the sides are 4 inches, 6 inches, and 11 inches. First thing you want to do is figure out what is my longest side. So which side is the longest here? It's 11. Add up the 2 shorter sides. What do I get? 10. 4 and 6. Is that bigger than 11? No, it's not. So no triangle. Remember, we want to make sure that we keep track of which side is the longest side. And sometimes that can be a little bit tricky. Here, pretty easy. But let's take a couple cases where it's not as straightforward which side is my longest side. Let's say I'm deciding between 4, 6, and 3 square root of 3. 4 and 6, well, 6 is bigger. But what about 3 square root of 3? That's our other competitor. Without a calculator, let's start to kind of build our number sense here of how this will work. Square root of 3 is between, what's bigger than 1, because 1 is going to be the square root of 1. But let's compare it with 2. Well, 2, in terms of square roots, if I wanted the square root to come out to be 2, well, that has to be the square root of 4. In other words, 2 squared is 4, and so the square root of 4 has to be 2. So this has to be a decimal between 1 and 2. Some decimal between 1 and 2. And so we have 3 times a decimal that's somewhere between 1 and 2 versus 6, which is 3 times 2. So we have 3 times 2, and then we have 3 times some number less than 2. 3 times 2 wins. Let's try a different one. 3 square root of 3, square root of 31, and 5. Now this is a little bit trickier. Three square root of 3. Again, you can feel free to use your calculator to get out the decimal. But here's how we could get it without a calculator. 3 square root of 3 comes from the square root of 9 times the square root of 3, right? Because 3 is the square root of 9. And so square root of 9 times square root of 3 is square root of 27. So this is square root of 27. The square root of 31 is the square root of 31. And 5 is the square root of 25. And so if I put them all in terms of square roots, I have square root of 25 versus square root of 27 versus square root of 31. Which one's the biggest? Square root of 31. So that's my longest side. And on all the problems that we do today, it's going to be really important to be able to keep track of which side is the longest. And make sure you're making that my C. But on all of these problems, on the homework I'm going to give you today, and on these problems on the notes, the first thing you need to check is, add up two shorter sides. Is that bigger than the longest side? If not, then we don't have a triangle at all. If we do have a triangle, this is the main thing we're going to talk about today, which is that we're going to look at the converse. I'm going to skip that one. We're going to look at the converse of the Pythagorean theorem. Now, before I go through all these in detail, let me back up, because we know what a converse is. So let's reason our way through what the converse here is going to say. This is the converse of the Pythagorean theorem. Now, the Pythagorean theorem itself said, in a right triangle, square the length of the hypotenuse is equal to the sum of the squares of the legs. In other words, c squared equaled a squared plus b squared. So the structure of my if-then statement was, if right triangle, then c squared equals a squared plus b squared. Now what the converse does, if you remember, the converse takes a statement and switches it. Switches them around. So instead of if right triangle, then c squared equals a squared plus b squared, switch that. If c squared equals a squared plus b squared, then what kind of triangle? Right triangle. So instead of telling you a right triangle, and you figuring out that c squared equals a squared plus b squared, we're going to use the fact that c squared equals a squared plus b squared to prove that we have a right triangle. But we can actually say more than that. Here's where we start writing down here. We can actually say more than that. Because if c squared is equal, exactly matches, then yes, we have a right triangle. But I can say even more, that if c squared is smaller than a squared plus b squared, then that triangle is going to be an acute triangle. And if c squared ends up being bigger than a squared plus b squared, then we're going to have an obtuse triangle. And that's going to mean what we're going to end up doing is we are going to test c squared up against a squared plus b squared. And we're going to see which one's bigger. If c squared is bigger, it's obtuse. If c squared is smaller, it's acute. If they tie and c squared exactly matches, then we got a right triangle. All right. Good to go on? Let's go on. So we are going to do a couple of these here. I'll do a couple of them, and then I'll be asking you to do a couple on your own to give you some practice with them. All right, here we go. 8, 10, 2 squared of 41. Remember, the first thing we need to do is to figure out which side is the longest side. 8, 10, or 2 squared of 41, which one's the longest? In this case, it's going to be 2 squared of 41. We can do the same reasoning we did before to say square root of 41 is between 6 and 7, square root of 36 and square root of 49. And so 2 times somewhere between 6 and 7 should be somewhere between 12 and 14. Somewhere between 2 times 6 and 2 times 7. So this number is a decimal somewhere between 12 and 14. So first thing I need to check, I need to add up the 2 shorter sides, which are 8 and 10. 18. This number is between 12 and 14. So is 18 bigger? Yeah, it is. Good news for us, we have a triangle. Make sure that you're always checking that part before you start doing the next step of c squared and a squared plus b squared. It's an easy detail to miss. Always check for it, because if this doesn't work, then we don't have a triangle, and we don't even need to test the c squared and a squared plus b squared at all. So make sure you check for that first. Now, c squared goes on the left. A squared plus b squared is going to go on the right, and they're going to face off. Here we go. C squared. C is my longest side, which is 2 squared of 41. Squared. That is on the left. On the right, we have a squared plus b squared. That's going to be 8 squared plus 10 squared. If you're using the calculator on this one, be careful. Do not use decimals and start rounding here. Without the calculator, the way that we can do this is that I can square each part. I can take 2 and square it. If I take 2 squared, that's 4. Times. I could take the square root of 41 squared. And the square root of 41 squared, I take square root of 41 and square it, and those are just going to cancel each other out, undo each other. So the square root of 41 squared is just 41. Exactly 41. On the right, 8 squared is 64. 10 squared is 100. So over here, I've got 4 times 41. Let's see, 4 times 1 is 4. 4 times 4 is 16, 164. Over on the right, 64 and 100. 164. Who wins, left or right? Oh, they're equal. They tie. They're equal. And if c squared is equal to a squared plus b squared, right triangle. This is why I said be careful of rounding. If you started rounding the decimals when you squared and multiplied and other things with the square root of 41, then you would not get that they were exactly the same. You'd start to round and then say that one of them is bigger than the other. But if we stick with the exact value, you should get exactly 164 with that value on the left. So avoid any rounding until the very end of the problem. That's just a general rule you're going to hear me repeat over and over again as we do these. All right. These next three I'm going to ask you to do on your own. On your own. I'll start you off on number 2. Remember, the first thing you should check for, actually the first thing you should do is figure out what the longest side is. That's pretty easy here. Which side is the longest? It's 13. And the first thing we need to check for before we do anything else is to check that if I add the 2 shortest sides, it's bigger than the longest side. 7 and 11 is 18. Is that bigger than 13? All right. Fantastic. We can do the rest of the problem. Then on all these, we're going to put c squared on the left. We're going to put a squared plus b squared on the right. And they're going to fight. See who wins. And that'll tell us what kind of triangle we have. C squared is bigger, it's an obtuse triangle. C squared is smaller, it's acute. If they're equal, like on the last one, we have a right triangle. So I'm going to give you guys here a few minutes to try this on your own and see what you end up with. Feel free to use a calculator to get some of these larger numbers squared.